Hi, my name is Leonid Titov. I'm a computer scientist, software developer, architect, and project manager. I'm gonna show you the second video about kiosk applications, as I promised. In previous video I showed the result, how does it work in reality. Now I'm gonna show you internals. That was like this interface. There is this one too. It looks great, but this is come on, it isn't finished yet. We will talk about this one. So this is a single page web application, and it is opened in the browser, as I showed you in previous video. You see, it scales to fit any kind of industrial monitor. So a little context. Actually, I am not on this computer. This is Windows 10. I connected remotely to a computer which is on the plant, and I'm not on the plant. You see, I can disconnect from it, and here we are. This is Linux. So why is this important? Because that computer connects to a closed network which is not connected to the internet. This computer is like a gateway. I will use this one to deploy, because there is an industrial computer which is physically on the plant floor. I showed it in the previous video. So we have to deploy first to this one, to this Windows 10 gateway computer, and then deploy deeper into the industrial network. So again, we have this UI. Here it is, and I will slightly update the UI. For example, change these two letters to something different. Let's do it. Let's leave it open. Close. Go to here. This is called 1107 server. This is actually a Go application, backend application, that pulls some hardware and provides web app interface, which you saw. This is main program. It is written in code browser, which allows you to do code folding, which is extremely convenient. Another interesting thing about this Go, it's not actually pure Go. It's a dialect of my own kind of. It handles errors on my own way. So I'm gonna show you. This is a web server. You see, here we have basically two servers. The WS1 is a web socket entry point, and this is a static file server which serves static files which are loaded first when you go to this address. So let's first see the static files. This is the HTML page, which uses my own framework with widgets. As you can see, it's not big, but where are widgets? I'm gonna show you in a second. Here we have my widgets library included, right? You have this macro, which is unfolded into, I'm going to show you what it is unfolded into. This is after the build process. It is unfolded into this. This is kind of conveniences, syntax conveniences of my own invention. This is a trying to reconnect, connection lost, etc. This plays audio in the browser, and here we are. We create widgets. So this thing is a widget. All this text, this, and this is a widget. This one, and this one. And here we created. You see, this is name. Let's change it. And I will deploy this one. There we are, save. We just create the widget and then update it with data. And I will show you the internals of this widget too. This is just a JavaScript. Here we have the scaling code. Here we have inter-process communication via WebSockets. Well, now I'm gonna show you the Go backend. Here we have the main program. Here we have a handle for WebSocket connection point. If you are a Golang programmer, you will be surprised to see this. What the hell is this? What the hell is this? Well, again, what the hell is this? What is this? This is a so-called Golang AMG project. I started, didn't yet publish it. I tried to make 2 proposals to Golang, and the guys from Google rejected it. They didn't like this syntax, so I implemented it on my own. I'm gonna show you what it unfolded into. This is a processed main program. So here we have, here is what I write, and here is what I get. Pretty convenient, huh? Again, I write this macro, and it is unfolded into this. It all happens at the build phase. The build is completely 100% automated. So this is it. What does this goroutine do? It just proxies the data to the actual handler. Now, let's go back. Here we have the main server, which runs the data. Here we have, well, let's start not from here. We have this goroutine, Modbus C1, This coroutine actually polls the hardware. It actually connects via RS485 to the hardware, gets the data, not hardware. In this case, we connect via Modbus TCP to the pasteurizers. I showed it in the previous videos. The hardware that runs on the floor plant. So this coroutine actually pulls the data from those stations, and this structure with data subset, here we read registers, and the fact is these are not registers, these are bytes, and I am converting it into 16 bits unsigned int. Here is it, registers, so-called registers. It's a Modbus industrial terminology. It's not like a computer register. And then that data subset is sent via a channel every 350 milliseconds to the server coroutine. We have 3 coroutines because we have 3 pasteurizers. Where is it? Here. 1, 2, 3. 1, 2, 4. And each one is handled by this coroutine. And then here we have a server coroutine. Here we get that data subset from a channel, copy it to, well, here are those coroutines are started. Here you see it. Pastor 1, 2, 4. And here we have IP addresses of them and data offsets. And when I get those data subsets, I copy it with different subset to this array, my pastor's data. Here you see it. This is the copying process. So this case, this one, gets data from the coroutines which pulls data from the hardware. And we have data in here. And then the front end via a WebSocket tries to make requests to us by this channel. This channel is basically here. Here it is. Here we send the connection from the front end. We receive it via a WebSocket here from connection read JSON, and then resend it proxy to the server coroutine. And server coroutine here receives it. If that request was a ping, we just respond with a timestamp. Note that we respond directly to the WebSocket. Why is that? Because there is no chance to conflict. And here we handle requests for data. We send the data, appropriate subsets. Here we have a slice of my pastor's data, this slice, and this slice from this array. And we send that data up to the front end via a WebSocket. So it's the front end that requests that data. I'm gonna show you. I'm gonna show you where that is. Here is the JavaScript. Here it is. Set interval and send requests for request type 11, 12 and 14 every 350 milliseconds, and the server will respond. Note that this server can handle multiple windows at once. So what did we change? We changed the name of the here, and here. This is the new version, and here we have an old version running. So I'm gonna build it and deploy. Let's do it. First of all, it's worth noting that build is 100% automated. It is written in Perl in my case. Here we have where it is. Well, here is the error handling syntax unfolded. I'm gonna show you a little more. Not here. Here. Well, not here. Well, it's a different thing. Well, you see it here. Connection read JSON failed at read JSON. If something happens, it will handle errors very smart way. Very smart way. So let's build it. F9 build. What the build will do? It will do all the pre-processing, assemble all the HTML, do the pre-processing of Go language, build. It is successful, and now it pushes the new version to the GitHub because I deploy via a GitHub. So all done, all successful. Exit. Now that's it. It's on the GitHub now, on the server in the cloud. Now to deploy it, I'm gonna show you. Connect via VNC to the plant computer. I can do it from home, from the Antarctica, from Australia, from anywhere on the planet Earth. And this one will update automatically. I'm gonna show you. I will connect to that TV screen. This is via VNC, and this is in the browser. I will close it. It runs in real time. This is not a browser now. We connected via the VNC to the remotely. So basically we are remotely connected to this computer and then remotely connected to this one, and it runs Chrome and kiosk mode application. I'm gonna open the one in maybe this one. Yeah, this is the one which is that is installed upside down. These two UIs are actual physical screens somewhere, and they will update when I will deploy. So here, to deploy, I just have to remotely run deploy the server. What does it do? Let's see inside it. It is Perl program. It does git pull first of all. Let's see. git push, git pull. This is it, and then it deploys it. So it connects via p-link to the industrial server on the plant floor, kills the process, server side process. Via executable name we get by pid-off command, and then kill. Copy a new file into there, make it executable, and then run it. This is all done remotely. So let's deploy, and notice how these screens will update, because what we changed, we didn't change the backend, we changed the front end. It will deploy, we deployed also. Let's run it. This is git pull. Now it killed backend process, you see. Deployment completed. Now it connected again. It detected the version change and updated itself. It's just like a magic. It's not a Docker, not Kubernetes, but in this particular case it's much more efficient than Docker, Kubernetes, or whatever else. So this is it. I'm gonna show you another example where error handling is used in much more intensively. This application works with database. So here it is. You see, you just do this. No, you don't need to run if error you don't need to do this. Instead, you just write so, and then so, and if something will happen, it will report db ping failed. This error handling is to be published. People will like it, but Google guys don't like. Too bad. So this is it.